everyone. I'm going to talk about cryptography, but first let me introduce myself and thank everyone that is worthy of thanks tonight. I want to thank you all for being here. I really appreciate it. I also want to thank Code Chrysalis for hosting this event and Blink for letting us use this beautiful office space. It's really a pleasure. My name is Bo. I'm from Atlanta, Georgia. I was an audio engineer for many years, and I recently transitioned into a software engineer. I went to Code Chrysalis last month, and now I'm actually in the process of working at a new job, and yeah, it's going very, very well. So, that's enough about me. Let's talk about cryptography. So, what to expect? I'm not an expert. I'm also a student of cryptography. This is not very technical. It's an introduction. Has anyone here ever used cryptography or implemented a cryptography algorithm? Yeah, a few? Okay, cool. Well, so my goal is to inspire interest in cryptography and show you where to start, not necessarily blow your mind. So let's get right to it. Motivation. What is cryptography? This is a very big definition. It comes from a dictionary, but basically, we want to figure out how to communicate between two people, some secret message. Some examples of when to use cryptography. So what I'd like to talk about is vocabulary for cryptography. This picture is not mine, but it is a very good explanation of how it works. There are three characters. We have Alice, Eve, and Bob. They're very common characters. Alice wants to send a message to Bob. It's important, and Eve wants to intercept that message. So when Eve gets the message, she can either read it or change it. Both of these are a problem, so we use cryptography to prevent both of those things from happening. How do we do that? Well, first we need some vocabulary. Plain text. So what is plain text? It is the message itself. It's easily readable by humans or machines. So it could be, for example, the text, email text itself. It could also be files on your hard drive. It could be text, images, or audio files. It could be a DVD video. So these are all examples of plain text. Even if it's a video or something, we still call it a plain text message. Next, we have encryption algorithms and decryption algorithms. This is the essence of cryptography. An encryption algorithm is a process that changes a plain text message into a, quote, difficult to read message. So I'll explain difficult to read in a moment. A decryption algorithm does the exact opposite. It is a process that turns a difficult to read message back into plain text. So we use these words. Sometimes both of them are the same thing, and sometimes they are very different from each other. But either way, when you put these two together, you get what is called a cipher. So if someone says a cipher, they're referring to a collection of algorithms that we use for cryptography. So there's another very important part, which is called a key. Now, a key, just like on a lock, it's a piece of information that tells you exactly how to use the encryption or decryption algorithm. So here's a very simple, kind of silly example, but I think it illustrates. Let's imagine there's a message. There's a secret meeting at 2:30. And we use this simple encryption. We're just going to add X hours, and maybe our key is 6. So if we encrypt the message, our cipher text, which is now our hard-to-read message, is that the meeting is at 8:30. I know it's really hard to decipher there. But the decryption algorithm is the same, however, the key is different. So this is just an example of a key is just specific information for how to use the algorithms. And when you decipher the ciphertext, you get back to the same original message. This is the essence of encryption and decryption. Let's see. So ciphertext. Now I use in quotes, it's a difficult to read message. What does that mean? Now, different algorithms are different, but once you have a difficult to read message, you have to decrypt it in order to read it. Now, how do you decrypt it? If you know the decryption algorithm and the key, you simply use the decryption algorithm and the key, and you decrypt it. Just like before, we just -6 from the time, and we know the message. Sometimes you know the algorithm, but you don't know the key. So it's possible to decrypt the message, but you have to try all possible keys. This is very important because some algorithms, there are so many keys, it's not impossible, but it takes a very, very long time to try all the possible keys. So there's also, if you don't know the algorithm or the key, you would have to try all possible algorithms and all possible keys. So another important thing to remember about cryptography is how many keys there are. It really comes down to what is the probability that someone can guess all of the keys and get the right answer. So let's see. Now there's another word here, a channel. So a channel could be a lot of things. Generally these days, a channel is like a wire or an internet cable or Wi-Fi. In the past, it could have been a telegraph, or even a person delivering a letter, or an animal delivering a letter. All of these are just ways of transmitting a message. So a channel can be a lot of different things, and you'll see some examples of how these channels have different encryption algorithms, and these channels also have different encryption algorithms. So this is a summary of what I just said with all the vocabulary here. Basically, you have a plain text message with a key and an algorithm. You convert the message into something that's hard to read. You use another key, and then you can convert it into an easy to read message again. When I first started studying this stuff, I was kind of afraid of the math. Sometimes you see math symbols and it looks confusing, but really it's just a fancy way of modeling this or this. It's not so complicated. It's basically take a message, encrypt it with a key, and then take the same ciphertext and decrypt it with a key. There are some variations on how this is done, and let's look at a few. There are two basic kinds of ciphers. We have historical ciphers with pen and paper. These were used a long time ago before we had computers. One of the first kinds of ciphers was called a substitution cipher, where you have a message and you replace each letter with a different letter. I'll give an example of that in a moment. There's also a transposition cipher, where you take a message and you just move the letters around in a different order. Now, modern days, we have fancier encryption algorithms. There's two basic kinds. One is called a symmetric key algorithm, also called private key cryptography. But the essence of this is it's the same key for the encryption and the decryption. So both people have the same key. There's even more modern is when it's called asymmetric key, where the encryption and the decryption have a different key. So this is really are replaced by another letter. Here's an example called the Caesar cipher or a shift cipher. So each letter in the message is shifted to the left or to the right. This example, a message might be shifted to the left. So if this is our plain text, this is our key, and we're using this Caesar cipher, the output or the ciphertext would be YBA. So we had a B, and that became a Y. We had an E, and that became a B, and we had a D, and that becomes an A. So that's a simple encryption using a Caesar cipher. Again, we use the ciphertext, we change the key, and we get the original message. So both of these, you're changing letters with a different letter. How many keys are there? So how many possible keys are there for this algorithm? Well, it depends on how long the alphabet is. So you could shift it by 1 or 2 or all the way up to 26. In this case, you could shift by 27, but it's the same as 1. So if you got a message and you knew it was a Caesar cipher, you could just by hand try all 26 and get it done in an hour or so. So this is not very effective these days. There's only 26 keys. Another example is a transposition cipher where the letters in the message are changing positions. So what is all this stuff? This is an example of a skittily cipher. So the message is written out of order. This picture here, this is called a skittily. There's a piece of leather wrapped around a cylinder, and you write the message across this way. So you can imagine if you write the message, "I'm hurt very badly, help," across something like this, and then you unravel it, then you get this message, which is a little bit more difficult to understand. So when you take this message here, you wrap it around the skittily. That's a mistake. Caesar skittily, my mistake. When you wrap it back around here, then you can read the original message. So how many keys are there with this kind of encryption? So really, it just depends on how big of a skittily you can manufacture. So if you wanted to make one very big and write lots and lots of rows on this, you could use as many as you'd like, yeah. Let's see. Now, our 1, so the output is 1. In these two cases, exactly 1 is 1, so the output is 1. Now, how does that work with encryption? Let's say we have a message, hello. This is the computer ASCII code for HELLO. If we have a key, which is river, and we use this operation, and we say, look at 1 and 1. So 1 and 1, that's going to be a 0. Again, we have 0 and 0. That's going to be a 0. But here, we have 0 and 1. Aha, XOR. That becomes a 1. You do this all the way across, and you get this message here, which is basically nonsense. So if you were to get this message, the only way you could go back using this algorithm is if you know this key. Now, how many keys are there? This message has 5 letters. Each letter has 7 bits. So this is how many keys there are with 5 letters. That's a pretty big number, but computers can do this fast. However, if you had 100 letters, this is an enormous number, and a computer could not figure this out in any time that's worth waiting for. So this is a very effective encryption algorithm, except the key has to be very, very long. So it's important. This is just, to me, a window into how cryptography works. Lots of XORs. Now, the last one I want to mention is that we have asymmetric key algorithms, where the encryption and decryption use different keys. Now, here's an example. So this is very technical. I just want to go over it broadly. Again, we have Alice and Bob. Alice uses a program, and she has a very large random number. So with her large random number, she makes 2 keys. With these keys, she shares one of them with Bob. She gives her key to Bob. Bob uses her key, makes this encrypted message, gives it back to Alice. She uses a secret key, and she can then decrypt this. So it's really technical, and in fact, I'm not even sure exactly how it's done, but it involves very large random numbers and the number of keys is something like 2 to the 256th power. It's very, very hard to guess all of them. So that is an overview of cryptography. If you'd like to know more, this is what got me started. This book by John Pierce, it's under $4 in the Kindle store. I highly recommend it. There's also the original gangster of cryptography, Claude Shannon. He wrote this paper back, I think it was in the 40s or 50s, and it's an excellent way to learn about cryptography. You can take a course on Khan Academy, or you can also take a Coursera course on Stanford University. So that's all I've got. If you'd like to check out these slides or ask me any questions, I think we have a few minutes for questions. Thank you very much. Cool. Any questions?
Questions from the audience? Oh.
Right.
We're not trying that again. All
Yeah.
right.
Cool.
Any questions from the audience?
Well, if you think of something, let me know. We'll be chatting.
I've got a
You've
question.
got a question, yes?
When did you start getting interested in cryptography?
Well, I remember I bought this book. It was on sale on a Kindle Daily Deals, and it's the first time I heard about this thing called information theory. And information theory is all about it's about probability, and cryptography, the essence of cryptography is that it would take a computer a very long time to guess all of the keys. And that's why you can trust that when you send a secure message, if someone intercepts it, it's going to take them hundreds of years to try all of the keys. And I think I probably got into this, I would say within the last 2 or 3 years, and I took some of this course. I've watched all of these videos. They're very, very exciting, and it's very interesting. I would say in the last 2 years or so, as a hobby. Yeah. Any other questions?
All right.
Well, thank you very much for your attention. Thank you.
So next up we have Leszek. Hot dog or not hot dog?
Hello everyone, my name is Leszek. I work for a company called CookPad. I work as a machine learning researcher. So, as the name of the company suggests, anybody here heard about CookPad? Okay. We deal a lot with cooking. So users upload recipes and they upload photos of what they cooked and what they want other users to cook. So as a machine learning researcher, I look mostly all day, I look at photos of food people uploaded. So I used to talk about different foods and different vegetables that we can use machine learning on, but people always ask me about hot dogs. I didn't know why until someone told me there was a show on HBO, which I've never seen, and apparently someone made an app which detects hot dogs, and it just says hot dog, not hot dog. So how can you make an app like that by yourself at home? But in this tutorial, we won't be making an app that says hot dog, not hot dog. We'll do one more step. We'll make an app which shows where the hot dog is, using a nice kind of a dramatic filter that colors the hot dog, and this colors everything else. So what are we going to use? If you want, if you can read Japanese, I have a blog post on the company blog, which is basically half of this talk, and then the other half you have to pay attention. We'll be using some data from Kaggle, which is freely available. We just need an account. And we'll be using the TensorFlow framework with a Keras kind of simple interface to TensorFlow. And then to visualize, we'll use Vue.js and TensorFlow.js. I'll be showing some code and some diagrams, so it will be a very quick demo. But you can see details in my published repository, which will be on the last slide. So, what is deep learning? Well, in case of images, this is a typical image of two hot dogs. It's 124 pixels by 224 pixels. Each pixel, if you look very closely, has these little dots. Depending on your screen, they could be aligned differently. But it consists of red, green, and blue dots on these screens. So we can say that any image, any image stored in a computer is a 224 by 224 by 3 red, green, and blue value matrix. Well, it's not a matrix if it's three-dimensional. We say it's a tensor, and then it's a TensorFlow, something that TensorFlow can work with. If you've worked with images, you might have heard of other image encoding systems like CMYK or Lab or HSL or other things. Some print shops will tell you, we can't print your image because it's RGB. You have to convert to CMYK. Or then you get some some Adobe software converted, send it to them, and it works. But what if you could convert from RGB to hot dog, not hot dog? Well, there's this gap here that needs to be filled. How do we do that? Well, that's deep learning. Deep learning is something that can convert from one space to another space, roughly speaking. But seriously speaking, in 2012, deep learning for images got a serious boost thanks to some researchers who came up with a model which is a series of filters, basically, that take an RGB image to 24 to 20. It's basically 6 years after that, and we have models that do things like segmentation, color cars in one color, people in another color, bicycles in another color, the road and the trees in yet another color, or instance coloring. Each car is a different color, or depth. With depth sensors, they gather data, and then they train another model to take an RGB image and guess the distance from the camera. So that's also possible in 2018. We'll be doing something simpler, and we won't be talking about training the model so much in this talk. That's a huge topic. So just think about training as a secret sauce. You just put it on top of the hot dog and it tastes good. First, you need to prepare the data. You can download this data set from Kaggle, like I mentioned. Someone got a larger data set containing a lot of different foods, separated the hot dogs, and took a number of other foods, mixed them together, and made it a hot dog, not hot dog data set. So we have that. On one hand, we have different hot dogs. On the other hand, non-hot dogs. And that's where we start coding. Keras is a mini framework on top of TensorFlow. It used to work on top of other frameworks, I think it still does, but now it's incorporated into TensorFlow. So it's a framework in a framework. And the cool thing about Keras, it has a lot of image processing features. So before you do training, you can augment your data. Why do we need to augment our data? That data set has about 500 images of hot dogs and 500 images of not hot dogs. The model can quickly learn that one of those 500 images is hot dogs and one of those is not hot dogs. It will just overtrain. It will remember all 500. So we need to make it a little harder for the model and make it like ready for the real world. Sometimes the light changes, sometimes the angle changes. We add more hot dogs using the hot dog images we already have. And in code, it's just one line. It's a long line, but it's one line. And we can change the width of the image, the height of the image. We can flip the image horizontally or vertically. Next, we build a train generator. A train generator is like any generator in Python. It's something you can run a for loop on. So for image in generator, and then it gives you images. So this train generator will use all images in the unzipped data set, and we'll divide them into two classes, which are the two subdirectories, not hot dog and hot dog. Then we build the model. We build the model in Keras. Another thing that Keras has is built-in models. Somebody trained some models for some purpose, and we can reuse them. Like I showed on the slide with the big model, we can cut the part that we don't need, add another part, all using Keras, and using that base, we can create a new model that serves our purpose. So, from Keras, we use a model called MobileNet. MobileNet can recognize 1,000 categories of objects, including 160 categories of dogs, or different breeds of dogs. We will not be using that top. We'll only use the filter part and add our own filters for hot dogs, non-hot dogs. It sounds like a waste of time, but we can retrain it so that it's more specialized to our hot dogs. What we do at work, for example, there are classes which are not in the 1,000 categories that are trained on MobileNet. For example, Japanese vegetables don't come up here. So we have to take the original model and train a different top on that model. So first we need to remove some of the features that the model created. For that we use a convolutional filter, which is a convolutional layer. Convolutional layer is basically a very general filter. You can increase brightness, contrast, modify colors. It's very general. It has a huge number of parameters, but it can learn. So we add one like this. Then we add another one like this, but this one will have only two outputs for each of the 7 by 7 pixels of the minified image. And the meaning of these mini pixels will be there's a hot dog in this area or no hot dog in this area. And with only these two filters, what we get is a heat map of where in the image, well, a 7 by 7 heat map, of where in the image hot dog might be. And we'll use that heat map to visualize. The problem is we don't have this information in the data. In the data we only have there's a hot dog in this image or there's no hot dog in this image. There's no information where. So we need to add two more layers. One is a pooling layer, which averages the 7 by 7 heat map and only leaves out an average value of all the mini pixels. And then there's a logic layer, which squishes the average into the space of between 0 and 1. That's basically all it does. So we will train the model to say 0, 1 if it's a hot dog, or 1, 0 if not a hot dog. how do we train the model? Like I said, I won't explain details, but you can do it with chaos. First, you don't train the base model. It will be much faster if you don't train the base model. You only train these two filters. These two don't have trainable parameters. So only these two are trained. Compile the model. Basically, in TensorFlow, a model is a calculation graph. So TensorFlow is a language inside a language. The model we built is like a program. Take the data and do this calculation, do this calculation, this calculation. That model is compiled to your GPU or CPU or whatever you're running your model on. So you need to compile the model and give it some metric of what you want to achieve. You can see this metric while training. And then you attach the train generator, which with every loop gives you an image and the label of the image. And train it for 10 hours. I also put a higher value on the non-hotdog class. Why did I do that? It seems to work better this way. That's another thing with machine learning. You do a lot of experiments, and you sound sciencey about it, but actually it's a lot of try and fail and try and fail and try this parameter and this works better, and finally you get something that works and you show it to the boss and then it gets deployed. Maybe. On my MacBook, training takes about 21 minutes. It doesn't have a GPU. So if you download the Jupyter Notebook, the Python script from a repository, you can run it on your laptop and it won't take too much of your time. You can train that model, or you can download the ready trained model from the same repository, which I saved and exported. And the saving and exporting part you can read in the TensorFlow.js tutorial. But what you get when you save and export is a ton of little files and one JSON file which describes them all. All those little files contain parameters of all the layers. Some of them are from the base model, which is quite big, and some of them will be from the model, from the layers which we added to the model. And then you can visualize. You visualize using TensorFlow.js, and I chose Vue because it's really quick to attach to any simple HTML page. Has anybody here used Vue? Oh, not so many people. It's really cool. It's really quick to learn. It's a mini framework. So in TensorFlow.js, you run load model, and then you point it to a URL obtained by the browser, and that's really cool. And then there's one infinite loop of the visualization. The way I made it, I used a video camera, a webcam, a video tag. I copy the pixels off screen every time I can get a frame. It's not 25 frames per second, but it's quite nice. I copy them into the canvas tab. Then I run a pre-process function to change the pixels into data which the model can use. I run predict on that one. Predict means just run the data through the model, get the output. And then I run post-process on the output and visualize the effect. Post-process is the big function which visualizes everything. So this is the loop. Get pixels from the off-screen canvas tab. Post-process, run model predict, post-process, and then copy to the on-screen canvas tab. That's it. So what does pre-process look like? This, like I said, prepares the data, the pixels into data for the model. So this takes the 640 by 480 camera image, shrinks it to 224, 224. Most models like square images. Don't know why. So it resizes it to 224, 224. And then it converts the integer RGB values to floating point numbers and divides by 225 because the integers are 0 to 225 and we want something from 0 to 1. And returns the contents which will be used by TensorFlow. Note that we are using TensorFlow to resize the image. The benefit of that is that TensorFlow JS is using WebGL. It's accelerated. If you have any GPU on your machine, it will be accelerated and it will be really quick. It's quicker than doing it in JavaScript or applying some other features. Then we do post-process, which is a huge function, so I'll cut it into two pieces. The output of the model are two heat maps. One is not hot dog, another is hot dog. We might have one heat map. Again, the training works better if we have two, and nobody really knows why. For visualization, we only take the hot dog heat map, and we'll expand it to 640 by 480, and we can use TensorFlow to do that. Then what we do, to make this cool effect, which I hope I have some time to show you, we calculate the grayscale value of the image by basically adding R, G, and B of the image. Let's heat map multiply squeeze. Oh, shuffling somewhere. Then we take the heat map, reverse it, and what we do is we multiply the heat map by the original image to get the colored part, and multiply the grayscale by the 1 minus heat map to get the gray part of the image. And we use the GPU for that. So now I'll show you the demo. Let's hope it works. Okay. We need to access the camera. Can you vaguely see my face? So this is live. I'm opening a hot dog package. So you can see it's not cheating. It's a completely new hot dog. It works. So you can see that the lightning effect is following the hot dog. Oh. Mostly.
There we go.
Yes. Also works with pictures of hot dogs. In case you continue to have a balcony. Laser. Oh.
Hot dog arm.
Yeah, it does react to arms sometimes. Like I mentioned, you can see all of the code, including the code I haven't shown you, on my GitHub repository, which I made for this event. If you have any questions, you can send me issues, ask now, ask during the meeting session, anytime. Thank you.
Are there any quick questions? All right. Oh, okay.
You mentioned features, like the model would accumulate more and more features as you go down the pipe, but what exactly is a feature?
Right. Roughly speaking, if we use one convolution layer, it can react to things like horizontal lines, vertical lines, very simple features that are not colors, but like a step up from colors. And then with 2, 3, 4 layers, it can react to circles or squiggly lines or letters. And if we put like 10, 15, 20 layers, it can see cats, dogs, faces, cars, things like this. So a feature is something appearing in the image, which we can kind of repeat in different images. So multiple images of cats have cat features in them.
Cool. All right. Next up, we've got Sam.
goes forward. Oh, I see. Okay, hi everyone. I'm not a hot dog. I'm Sam. We don't need AI to tell us that, I guess. So I'm gonna not talk about a tutorial on how to build something or code something because I'm still not quite that far myself. But I am gonna talk a little bit about why, as CEO and founder of a company called Amplified AI, am I learning to code? And this is a little bit, I'm cheating a little bit because I actually started to learn Java and Python in 2003, but then I sort of stopped using it for like over a decade and totally forgot everything that I learned. So I'm sort of relearning, but I still think it's a worthwhile topic to cover. So let me ask first, how many people here work as a developer? Like that's your day job. Okay. How many of you don't work as a developer, but you do code, you know how to code? Is it the same or something? Okay, cool, awesome. So it's good for all of you. So number one, just my perspective from this is as a founder of a company, is this an important skill to have? And I wanted to come at that from a couple angles, but let me also ask, does anyone here have dreams like would you maybe one day want to start a company or maybe you already have? Is that something that anyone here cares about, is passionate about? Oh good, I was really worried it was just going to be no one. What am I here for? So do I need to code to start a technology company? Let's look at some examples first, just to give some context. So here's some companies that have CEOs or had CEOs that knew how to code and started a technology company. And obviously these companies have all been successful because hopefully we all recognize them. And then below, here's some companies where the CEOs don't. They don't know how to code. They are with varying degrees familiar with technology. So for example, the CEO of LinkedIn, Reid Hoffman, he had experience with working in technology companies, but Jack Ma, who started Alibaba, had no experience at all with technology companies. He and still actually is pretty public about saying that he knows nothing about technology or programming. So okay, it's not required. Obviously, you can build a successful company without knowing how to code. But why? So why would I, knowing that, have made this choice? Well, there's a couple things. So one is just like for personal development reasons, and I'm only gonna have one slide on this because this is not the main thing I want to focus on today. But I view it kind of like brain yoga and self-improvement. So my background in business is sales. That's what I've done a lot of. My day-to-day job as CEO, I'm talking to a lot of people. I'm doing a lot of things that are very different from what you do when you're developing. I'm usually running from one thing to another thing, very quickly changing gears. And so it's actually kind of a nice break. It's a nice opportunity to do something very different from what I'm doing in my day job, and it actually kind of helps me be a thing. But it's a job, and there are actually things that you're supposed to do as CEO. And there's actually some great resources. There's a great Medium article that I have here. That's a link. I can give you the URL later. You can check the material. I'm happy to make it available for some more detailed stuff. I'm going to set aside the fundraising and the board part because not everyone fundraises and not everybody has a board, but I'll focus kind of on what I think is like two sides of the CEO job. One is sort of the yin side, which is the empathy. And this is communicating vision. What is the vision? Why does this company exist? Building a team, recruiting people, but also after you've recruited people, keeping them happy, successful, motivated, working together. And then sales and marketing. And this is more of the external facing stuff. And then the execution side, which is sort of the yang here. And that's planning product and the business. What's your strategy? How do you execute on that? What are the steps that you take to go from A to B? Building culture. As you build a team, you need to also have a process. What do I do? It could be as simple as what do I do when I want to take time off? Who do I ask? Who do I talk to? Do you always come to me, or should I ask my manager? Do I have a manager? What is a manager? Also, how do we deal with what's our process for customer complaints? If a customer's upset, how do I deal with them? These are all things that get built into the culture, and it's an active process. If you don't define what culture you want, it'll just sort of build itself, and you wind up with whatever you get, which is not a great way to build a company. You usually want to be thoughtful about this. And the last thing is setting goals and measuring progress. So how do you know that you've actually executed on any of these things and these plans is by setting a goal and saying, did we meet that or did we not? And so you need a way to measure that. So these are kind of the things that a CEO does. How does this relate to coding? So I have kind of just a word cloud of some things, some verbs that people use to describe what a CEO should do. this is a little biased towards sort of what I think, I guess, since I took it from places that I agree with. So other people might disagree with you. Some people may have a more, I guess we'll say, authoritarian view of what a CEO should do. But these are some verbs that I think describe what a CEO really should be doing. And so why does it help to code? Even if I'm actually not contributing directly most of the time to stuff that we're doing at my company. And by the way, we're doing everything from AI in terms of actually researching models and then developing them, not just using kind of frameworks where you plug and play, but really going from the bottom up to it, to building a SaaS app to deliver those things, to doing quite a bit of data processing. So we really cover the whole range of technology spectrum. It's very complicated work, not something that I'm able to really contribute to in an active way. But because I work on this in my free time, I can develop an appreciation and understanding for what the people who are developing this, who my co-founder and CTO, the developers that he works with, contractors, what they're doing. And I think that's a really important thing because that builds the empathy. You can't really have empathy for someone if you don't know what that's like. So just having the experience, having the personal experience of like, I thought that was easy and then it wasn't. And why did this not work? Okay, now I have to go and like check and I got stumped, and going through that process of finally figuring out, like maybe I found some answer somewhere on a forum, just understanding that that's sort of the way that the sort of day-to-day development work goes is very helpful. Second is it helps me to ask better questions and be more helpful. So I don't know if any of you have had this experience, but especially if you've done any development, you're working on something and the boss comes and well-intentioned, wants to help, but basically makes you waste about twice as much time as you would have otherwise by asking a lot of questions, probing, and trying to sort of, butt in, basically. I am pretty sure I've done that a lot. Not intentionally, you sort of realize afterwards, you're like, oh, that was really stupid. So it helps me to sort of understand where I can actually help, where it's valuable for me to be involved, and what kind of questions I can ask to help sort of push people to think in a way that might help them solve their problem. And sometimes it's as easy as me just saying, actually, very recently, we were stumped on a problem and I said, why don't you take a day off? And that was actually kind of the thing that was needed, was just to step back. And I was able to say that because I could sort of recognize that situation where I knew I had trouble before. I think I've lost it here. Well, I know I had trouble with something before, and when I got stumped, what I really just needed was a little time away. So saying, why don't you take a day off, or why don't we work on something else? And that was sort of a thing that actually saved us time by being able to suggest that. Another thing is shortcutting BS and focusing on issues. So sometimes it's frustrating as a manager or as a leader to sort of have someone pushing back on you saying, this is going to take this long, or we have to use this particular framework for this reason. And so being able to understand if that's a legitimate concern and that person's coming from a place of really thinking about what sort of is the best solution to a problem, or if there are some other things coming in. And people don't generally, I think, want to go really push hard for a framework because they're trying to be just to sort of mess with you. It's usually a true conviction, but sometimes it's more about, I don't want to go learn a new framework, or sometimes it's more about, I have these other kind of reasons that I really want to go to this way. And so being able to just sort of see through that and cut through that to say, let's talk about what's really important here is helpful. And then facilitating interaction between sales and development. A lot of companies have a lot of tension between kind of the internal development side and the sales side. And they kind of butt heads, and you get the sales guys kind of going out and making promises, and then they come back and it's like, you said what? So that's not entirely avoidable, but we can sort of minimize it by building a culture where from day one, me as sort of the main salesperson, the CEO, am thinking about that and making an effort to be reasonable and push on both sides to say to the development side, well, hey, wait a minute, guys, here's what the customer's really saying. And that sounds possible. We should be able to do that. Let's think about how to do that. And also being able to push back and say, well, wait a minute, this customer is actually being unreasonable. This Japanese company wants just an unreasonable amount of security, and meanwhile they have like all of their accounting records in this easily hacked sort of terrible security place. So what are they asking for? And being able to guide that towards a productive conversation instead of just sort of throwing up our hands. On the execution side, it helps to understand timelines and costs, just to know, because as CEO, you're making promises to everyone. You're promising your internal team, hey, this is going to be ready by this date. You're promising the board, you're promising customers, hey, we're going to have product for you, here's the next steps. you're constantly making promises. And if those promises don't get met, even if it's not your fault, it basically is, because you're the one who made the promise. So having some greater confidence in your ability to do that by having a sense of what people tell you and being able to go and ask the right questions to the development team and understand, okay, you know, they thought this was going to take 2 weeks. I think it might take longer because there are unforeseen consequences, and I can tell that they're sort of striving to go for something that's not realistic. So, you know, being able to address that head on and say, I think this is probably more like a month, guys. Does that sound right? Or if they say it's, you know, hey, this is going to be 2 months, like, well, wait a minute. Why? Shouldn't this exist somewhere? Let's go do a little research. You know, we, as an example for us, we have this text highlighting feature that we are building, and there's a bit of a debate, should we build this ourselves, or is there something we can use? And it turns out there's some great stuff in React, which is the framework we use. There's some great stuff for that sort of already does this, is very well suited to our needs. This is not an issue where we need to, you know, hand roll something. We can basically go and plug that in. Meanwhile, on the AI side, you know, when we were first starting, there was a debate about, you know, how much should we try to leverage things that already exist. And it was pretty clear that it would be a massive waste of time to leverage things that already exist because our particular application area is so focused that we need to really do it from scratch. Second is planning more strategically. And this kind of is a little bit softer, actually, but just the process of thinking about developing, I find is actually a very strategic thing. It's a lot of analytical thinking, and you don't just sort of fly by the seat of your pants and make decisions. Or if you do, you find out that you sort of have to rewrite all of your code anyway. But you kind of have to think a little bit more holistically when you're making decisions as part of developing a web app. You can't just make things in an isolated vacuum. You have to sort of think, well, if I make this particular decision about like how I build my user database, that impacts a lot of things down the road. Is this like a one-to-many thing? Is this a mini-to-many? And those actually are important business things to think about. So it helps me think about the business. Well, wait a minute, should our users be using this as a mini-to-many type of situation or a one-to-many? How should I structure our users? What makes sense? And we sell to corporates. So there is sort of a structure that matters, and there's going to have to be admin and kind of super user and various tiers of access that people have. And so then number 3 is being the culture that I want to build. So I mentioned that building culture is an active task. I believe that work takes a lot of your time. You're at work, you know, theoretically 8 hours a day, 5 days a week. That's a lot of your waking time. It should be something that's interesting to you, but it should also be an opportunity for you to go and accomplish more. So some people just want to sort of show up, go home, and then spend the rest of their lives doing other things, and that's totally fine. The culture that we're trying to build at Amplify, but also you want to push. So just having that sense of what's reasonable. So here are some reasons not to learn how to code. The opposite. So, and this is surprisingly, a lot of people, a lot of other founders that I talk to will throw these up as saying like, I just need to learn how to code because, you know, then I won't need my technical co-founder, and I don't have to dilute myself as much, or, oh, you know, I don't need to hire a team that way, I'll just build it, and I'll just do it myself. That's not a good reason to say that you're going to learn how to code. That's kind of ego speaking, and that will be ultimately more self-destructive than it will be beneficial. The second is, I need to know how this works so I can control my development team. People might use different words. Maybe they'll say manage. You know, I need to know how this works so I can manage my team. That's also a bad motivation. That's also, again, ego speaking. If you feel like you have to go control your development team, either you're the problem or they're the problem. Usually you should actually be able to just communicate what you want done and be working with people who are motivated to get that done. So it's really not a good motivation to want to control. Some good reasons though. If you want to develop better communication and empathy, that's a great reason to learn how to code. If you want to network and recruit, to go and participate in a broader community, that's a great reason to learn how to code. And generally, if you just want to kind of improve your analytical thinking and creativity, that's another great reason to learn to code. So that's it. Thank you very much. And any questions?
So many languages and frameworks out there. What kind of starting point would you recommend for people to start learning them?
So this might be, I had that problem where I wasn't sure what to start with. Granted, I had my sort of background in Java and Python, so that was sort of the obvious thing to start with. I ended up not going in that direction, actually. My answer is actually that it depends on what you're doing. You'll be more motivated if you're learning something that you feel relates to kind of what you want to build. So in my case, actually, I sort of learn a lot of things at once, but the main thing that I focus on really is learning R, and the reason is that R is a great sort of, it's kind of more like a pseudo language, but it's a great way to do data science, and we're a data company, fundamentally. Actually, I didn't tell you guys what Amplify does, but we do patent AI, so we make it a lot easier to access patent data. So we have like 100 million patents, every patent in the world in multiple languages, and there's a lot of data in that. So to better relate to kind of my team and the business and our core values as a data-driven company, I decided to really focus on learning R. But then that sort of led me into like learning more functional programming languages, so a little bit of Elixir. And again, it's just, this is all because all of it kind of ties into what we're doing, and having a focus on data where it does kind of make sense to take this approach. But you know, if you're more of a design-oriented person, you know, maybe start with JavaScript, right? If you're more like wanting to do really basic machine learning and sort of get your feet wet there, like go learn Python. Python's a great way to start getting into that. So I think it just depends. And a great thing to do is just ask people who are developers, tell them what you're interested in, and see what they kind of mention. One and then two. Start with the front one.
As a kind of non-technical CEO that can code with a CTO, what's the relationship with your CTO, and what kind of roles and responsibilities? Like, where's the line between you guys?
The line is very clear. So he's the CTO, and so all of the developers that we work with basically report to him, and you know, it's very we keep that very clear. So I don't want there to be any confusion. I don't want to create a situation where you know, a developer comes to me and says, you know, hey, I've been thinking about this in a casual way, and I say like, oh, you know, that's interesting. That sounds like a good idea, and then we find out 2 weeks later that they've been working on that instead of the thing that the CTO thought they were working on. So that's a good point. I think it's worth being careful about and making sure that it's clear. Our relationship is basically that we communicate a lot. So he helps me with when I have questions, even if they're kind of dumb questions, and it's good for us to be able to talk about that. We regularly talk about the technical side, and kind of he rubber ducks ideas. So even though I'm not fully understanding everything, or maybe can't contribute a lot to the conversation, he's able to sort of talk through it and lay out his logic, and so we get an understanding for how we each think. And we also do the opposite. So I try really hard to make sure that he's in front of customers. It's sort of the opposite of what I'm doing. You know, I'm putting myself into the technical seat sometimes, but also putting him into the sales and marketing seat to say, you know, this is what it feels like when you say something and you get back a response like this from a customer. So we try to keep it very good communication between us, but in terms of communicating with the team, very, very clear division of sort of who's making decisions and giving orders.
So sales, marketing, product kind of reports to you, development reports to CTO.
Yeah.
Yeah.
That's right. Yes.
Yes. So when will you be learning, and is there any point where you will say, okay, I've learned enough, and now I'm going to practice something else?
Probably not, because I like it. For me, it's just fun. So I don't think I'll stop because it's sort of, there's a deeper motivation. In terms of being able to be a CEO, I feel like if you go back and you look, for example, like Steve Jobs is always something people talk about, right? He wasn't a programmer, but he started a technology company, and you can hear when you go and listen to him talk about technology that he understands sort of the issues. So I think you always have to be competent and able to speak. I might not be able to go and develop cutting-edge AI model, but I need to know the difference between plugging something into TensorFlow using sort of like pre-built stuff, which is awesome and very powerful, but the difference between that and truly creating something that could be a published research paper. So I think you have to always stay up to date with what's going on.
Great, thank you.
you.
Last but not least, Kevin.
Just check this real quick.
How much time do we have?
You 15 minutes.
Hi, my name's Ben. I'm a bit awkward, so don't mind me. How many people here are familiar with APIs? Or how many people know what API stands for? Pretty much everybody. That's good. All right, so are you taking a picture? So today I want to talk about API technology coming out of Japan. This is the agenda. I'll introduce myself, talk about my love of technology, tech, communities, and questions. So my name's Kevin. Most people call me Michi or Totoro. I'm a big Totoro fan. I have a tattoo right here. You can look at it later. King Kevin, my middle name is means king. I run Design Japan, or I'm one of the main organizers of Design Japan, Dev Japan, and Go Japan. Design focused, dev focused, and learning, growing, education wise. I have a dog named Peanut. I love him. I lift heavy things. I like lifting weights. One of my mottos is love life to live life to love. And I pretty much have a full stack background. Programming, web development, back-end development, front-end QA, systems analysis, and network analysis. My hobbies deal with AI, AR, VR, and machine learning. And now I'm Locked In Rapid API's community tech evangelist. I get in front of crowds and embarrass myself. And my focus since I was born has been communities. I love people, even though I'm scared of them. And to inspire people. Just real quick about Locked In Rapid API, because that's how I get paid. It's an API marketplace with 8,000 plus APIs and 500,000 plus developers and 400 billion API calls a month. I just started, so I'm still learning. So, and if you want to check it out, you can scan a QR code. This is basically the business model. We work with API providers, which is who I've been spending my time with a lot recently, which is why I'm talking about it today, and developers, people who consume API technology. So yeah, why I love technology. It's got to take a little detour to get there, but I love people. I love technology, and the weirder the technology, the better. So I love the hot dog talk. That's gonna rock me to sleep tonight. Technology expands reach. Technology connects people, and API technology expands reach and makes that connection more scalable. With technology, you can reach more people. You can, before, like 100 years ago, you couldn't talk to somebody across the world, but now you can. And that's where I want things to go. Just like a little sci-fi nerdy thing. If you think about any sci-fi movie or any sci-fi film or book, in the future, 1,000 years from now, 100 years from now, there's no multiple countries. Everybody's like one human race exploring the galaxy and doing that, all that kind of stuff. And that's kind of the direction that I'm trying to push people to go into. Yeah. Anyway, so who knows? Has anyone ever heard of Ship and Co? Oh, one person. Okay, that's cool. Anyone ever heard of Bento and Co? ANA. Anyone ever heard of ANA, the airline? Here. So he had the idea to make Bento and Co, which is to start shipping bentos like all over the place. And through doing that, it was a pain in, can I curse?
Sure.
It was a pain in the ass. So he's like, I want to simplify the process of shipping. So I'm going to make a shipping company. And in order to optimize that, shipping code, which is like a spin-off of Bento code. So yeah, they raised 100 million yen from Spiral Ventures. And the reason why he made shipping code is because through shipping with like Japan Post and FedEx and UPS, they all have their different standards. They all have like different ways of doing things. Some people want them to hand write an invoice to attach it to a box, and he thought that was annoying, so he made shipping code to kind of simplify that process. So they're doing really well, and now they can ship through JP Post, DHL, Carrier Pigeon, whatever. They can do it all, and they partner with like all the e-commerce sites like Amazon and Shopify and all that stuff. So yeah, and the reason why, again, like I deal with technology, I know a lot of random ass information. So I meet a lot of people and talk to a lot of people. So I've been like deep diving into like just API technology and API communities in Tokyo, especially on the Japanese side. So I started finding out about more of these companies. So Edom does they buy and sell used cars, to put it simply. They do a lot of stuff. They're a mobility company. Rental cars, bike shares, used car sales, online and offline. They do everything. So now they have a API focused on car sharing, or the main thing is car sharing, but their API lets you see their whole list of cars. You can buy insurance. They allow you to do more customer-to-customer selling and list used cars online and offline. And they own Gulliver USA in America. So yeah, they're basically trying to be the primary API for selling for all things cars. I don't know of any other car company or used car company or boat or airline company except for ANA that's doing APIs that'll let you sell cars or buy cars, or again, they also do like rentals and bike shares and stuff like that. So I'm just throwing all this information out there because I feel like it's kind of short on time. So ANA. Oh, and Shipping Co is the only company so far that I think has the open API. And they just opened up their API. So if you want to build something based on shipping and invoicing, you can use Shipping Co. The Edom API, I can't remember if it's only open for me or if it's open to the public, but again, I've been talking to these people, so some of the stuff that they tell me, I'm not actually supposed to tell you, but just ignore that. So ANA. Everyone knows ANA, so it's kind of like pointless for me to talk about it, but ANA also has API that they're creating that's going to be very similar to Google search. So they're working with Star Alliance, and it's kind of how it looks, but they're making like a digital service platform that connects all airlines, so you can build apps similar to like Expedia or Google search. You can make your own like flight search engines if you want, and build people for it. But yeah, they're making a digital service platform that basically connects all of Star Alliance and any other airline carriers that want to get on it, so that so that you can provide apps to customers to get more information about flights, whether it's like Wi-Fi on the airplane or pre-boarding or whatever. Right? Currently, you can only use like ANA's app or JL's app or whatever, but now with their API, you can make your own app and sell it to customers if you can design one that looks better. And this is Peanut. It's my dog. Again, I love my dog. He's a pit bull. Yeah, and if you're looking for work, or if you just want to shoot the shit, then you can reach me at this link here. But if you are just looking for work, you can basically talk to me or Paul McMahon. He's another guy. He runs. He's the co-founder of Doorkeeper. How many people know Doorkeeper? Okay, so Paul McMahon is the co-founder of Doorkeeper. We both try and help developers in Tokyo find work when we have time. I didn't include my email, but just give me your card later and you can spam me with email. I do a lot of running around, so I'm not ignoring you. I don't want to say I'm busy because it sounds like I'm an asshole, but yeah, just spam me and I'll reply. And it's like and King Cavan, just Google King Cavan and my name, my picture will probably show up. Yeah. Any questions? No? Good?
No, that's
Oh,
my
well.
question.
So in the marketplace API that you're telling about Rakuten, are the reviews open to public?
Are the reviews?
Are the reviews open?
Oh, yeah.
Rakuten reviews?
Yeah.
Okay.
Yeah. You can. I'll give you my card later, or show you the QR code again later. But yeah, it's available and open right now. We just launched on the 11th, so last week, and it was all over. There's like 51 different media companies covered it. Yeah.
So just some questions about Rakuten and
Yeah.
API sales. Is Rakuten seeking to like dominate the selling or access to APIs, or what is their?
Rakuten is seeking to dominate everything. Just everything.
Well, so am I, but
Yeah.
is there someone who's already, some big company's already gotten into that and they're following, or is this a new thing, or what?
What, API Marketplace?
Yeah.
Previously, here, I'll just go back. Previously, there was Mashi and Rapid API. This Rapid API.
Okay.
But Rapid API, I believe, bought Mashi, or Mashi merged into Rapid API. And Rapid API was actually using Mashi as an open source marketplace platform or something, and then they merged, or Rapid API bought them. And they grew pretty huge, but through some late night business dinners, they decided to partner with Rakuten, and now Rakuten is bringing the Rapid API marketplace to Japan and all of APAC. So I'm not sure if I'm allowed to say the numbers, but we're planning to grow this very fast and very largely. So for API providers, it's very enticing, and I'm kind of tired from having meetings. And for developers, it's also very enticing too, because to put it simply, all these APIs that you use as a developer are spread out all over the place. You have to make multiple accounts, you have to create multiple billing accounts, you have to look at multiple sources of documentation, and just like shipping code with the different formats that they had to deal with for like JL and FedEx, not JL, for FedEx and like UPS, they had to look at, Thomas had to deal with different shipping companies and their different standards. As a developer, you have to also look at different documentation. Some of it is shit, some of it is good, some of the support is quick, some of it is slow. You have multiple stakeholders that you have to deal with as a developer. But the marketplace essentially solves that by standardizing the APIs that are on the marketplace. We have a standard that API providers must follow when they join the marketplace, so that everything looks consistent with the other API providers. So I can show you an example later, but basically it makes developers' lives
I don't know, like, it seems to me Rakuten's name recognition outside Japan is not that great. Are they hoping that the word Rakuten becomes synonymous with here's where you go to shop for APIs?
Yeah, pretty much. Where are you from again? I know we talked Saturday.
Yeah, it's California.
Okay, so you know Golden State Warriors, right?
Yeah.
So now on Golden State Warriors jerseys, they have like a big ass Rakuten sign, because last year Rakuten became like the primary sponsor of Golden State Warriors. And FC Barcelona, we're now the primary sponsor. For the past year, we've been the primary sponsors for FC Barcelona. basically Mikitani is trying to spread Rakuten, just like you said, Rakuten isn't really known outside of Japan, but he's trying to spread the name, and now we're getting into finance. Our mobile network is coming out, I think, either this year, this fall, or next fall. Like, Rakuten's doing a lot to increase its brand. So being known outside of Japan isn't really a long-term issue.
Cool, thank you so much. Thanks for coming to MiniConf. We're gonna have another one of these next month. If you're interested in speaking, please come and talk to me. We like having a good mix of talks that are really accessible for beginners and other talks that are like on the bit more advanced side. We want to keep them all.
Bye.